Welcome to today's lesson. So today's lesson is about soil fertility, and this topic is from agriculture from 2. And today you are with me, your presenter and your teacher, Andrew Cobby. So before we go far, let's look at success criteria for this topic. So by the end of this lesson, students should be able to first, they should be able to investigate the difference between fertile and infertile soils. They should also be able to state ways of maintaining soil fertility. So let's now look at the differences between fertile and infertile soils. So let's look at fertile soil. So on top of fertile soil, is the ability of the soil to provide and sustain high crop yields indefinitely. So on top of fertile soil, it means that soil should be able to provide as well to sustain high crop yields. So a fertile soil should provide all necessary conditions, all necessary which are required for growth of crops, and also so that the crop, the crop yields should be high. So all the necessary conditions should be there. That's when we say this soil is fertile. So let's look at this experiment. So this experiment is to investigate the differences between fertile as well as infertile soils. So in this experiment, you need to have the following apparatus as well as materials. So sample of a fertile soil and sample of infertile soil. Then you need to have maize seeds, you need to have pots or tins, then you need to have water and ruler. So let's look at the procedure of this experiment. So we have to collect a soil sample from a garden where crops have been performing well. It means that soil is fertile. Then collect another sample from a garden where crops have been performing poorly. It means that soil is infertile. Then you put the fertile soil in the first pot. Then put an equal amount of infertile soil in the second pot. So it means you've got 2 pots. The other pot will be filled with fertile soil. The other will be filled with infertile soils. Then you have to plant maize seed in each of the pots at the same depth. So the depth should be the same. The only difference should be the fertility of the soil. The other soil is fertile, another one is not fertile. Then you have to water the seeds in the pots. Then practice regular watering of the seeds with the same quality of water and same frequency. So the frequency should be the same. The quality of water should also be the same. Then observe the plants as they grow and note any different. So you have to observe as the plants are growing, and you have to observe and also to note any difference, and you have to build recording. Another step is measure the height of each plant using a ruler on daily basis. So on daily basis, you have to measure the height of the plants. So you have to record the results in a table. So like the table, like the one shown below, for a period of 2 weeks. So you have to record the results of that experiment for a period of 2 weeks in a table like this one, which is being shown. So this table, it has got time in days. It means I've got day number 1 up to day number 12. Then we have got two pots, fertile soil and infertile soil. So we have to be recording the heights of plants in each and every pot on a daily basis. So let's look at the results now. So the maize seeds germinated at the same time. So obviously the maize seeds will germinate at the same time. So seedlings in the fertile soil were observed to have a high growth rate compared to seedlings in infertile soil. So as we said that fertile soil, it provides all necessary conditions for the growth of the plants. It means seedlings in the fertile soil will have a high growth rate as compared to seedlings in the infertile soil. So let's look at the explanation now. So I'm saying that fertile soil provides the crop with all conditions necessary for growth. The soil has the various minerals required for proper growth of the plants. So infertile soil lacks some of the essential minerals and plants do not show proper growth. So since some of the essential minerals are not there in fertile soil, it means the plants will not show proper growth. The plants may show different deficiency symptoms depending on the missing minerals. So plants will show different deficiency symptoms based on what kind of minerals are missing in that kind of soil. So some of the symptoms, deficient symptoms that may be observed include stunted growth, whereby the crops are failing to grow. You have got crosses or yellowing of leaves. Find that the leaves they turn to yellow. Then you have got poor development of leaves, rolling or curing of leaves, then premature leaf fall. So these are some of the deficiency symptoms that may be observed when you're comparing, in the soils that are not fertile. So this is just a picture for you to appreciate the crops that have been grown in a poor or in an infertile soil. So the crops can be seen that they are really stunted. They are not growing in a proper way. So in conclusion, fertile soils allows proper growth of plant, while infertile does not allow proper growth of plants. This fertile soil has all necessary requirements for plant to grow well. So I've got a table. So this table is about the difference between fertile and infertile soil. So fertile soil, it contains all mineral elements essential for proper growth, while infertile may lack some of the essential uh, essential minerals for proper growth. So fertile soil has the light depth depending on the crop grown, while infertile may be shallow with respect to the crop grown. Fertile soil has the right water holding capacity. So infertile soil may hold too much or too little water to allow proper growth. So those are some of the differences. And fertile soil has good porosity, hence well aerated, while fertile may be poorly aerated. And fertile soil is free from excessive soil-borne pests and diseases, while in infertile soils there is excessive soil-borne pests and diseases. So let's look at maintenance of soil fertility. So a soil that is no longer productive or that which is less productive can be made more productive through various practices. So when talk of the soil which is no longer productive or less productive, we mean the soil which is infertile. So that soil which is infertile can be made productive again through the following practices. So the practices include application of organic and inorganic fertilizers. So organic as well as inorganic, they contain nutrients which may boost or may add fertility to the soil. Then talk of practicing crop rotation. So if you talk of crop rotation, some of the crops in the rotation, more especially if you include legumes, they may fix nitrogen to the soil, whereby increasing the fertility of the soil. Then talk of regression of soil pH, talk of controlling soil erosion. So if you control erosion, it means you are making that soil to be productive, because no soil erosion, it removes the top layer which is fertile. Then we've got time weeding control. All these practices, they help to maintain or improve the fertility of the soil, because weeds, they also use the same nutrients which are used by the crops. So if you timely control the weeds, it means you are maintaining soil fertility. Talk of practicing minimum tillage or zero tillage. Zero tillage also, it helps to maintain the soil fertility. Then practicing also intercropping. All these are some of the practices or activities which can be done to maintain soil fertility. Then let's look at the first one, which is application of organic and inorganic fertilizer. So this will replenish the nutrients lost from the soil, or this will add the nutrients which has been, or I mean, the nutrients lost from the soil. So since organic as well as inorganic fertilizer, they have nutrients. Therefore, if you apply organic as well as inorganic, it means the nutrients will be replenished into the soil. So organic manure also releases humus that binds soil particles, thus improving soil structure. So if you apply organic, it means you're also improving soil structure, because that's what humus. That humus, it binds the soil particles together. They also help to buffer the soil pH, thus preventing rapid changes in the soil pH. It means if you apply organic manure, soil pH, it's not easy to change the soil pH. So it maintains the soil pH. Organic manure acts as food and shelter to organisms, thus increasing microbial activities. So in other ways, organic manure, it provides a good working conditions for microorganisms. So it's very important to apply organic fertilizers. Let's look at practicing crop rotation. So this is the practice of growing different types of crops on the same piece of land following a definite succession. So what it means is when you are practicing crop rotation, it means this year, let's say I've got the same piece of land, this year you plant maize, next year you change, you plant legumes, the other year you change, you plant, let's say, sweet potato. It means you are rotating, you are doing crop rotation. So crop rotation is very, very important. So crop rotation improves soil fertility in the following ways. So the first one, it controls specific soil-borne pests and diseases. So there are other pests and diseases. They attack specific crops. So if you rotate, it means you are breaking the life cycle of those pests. So it's very important. Then ensure maximum utilization of soil minerals from all horizons. So there is maximum utilization of all nutrients, all minerals from all horizons. Since if you are rotating, you find that other crops are deep rooted, others are shallow rooted. So all the minerals will be utilized in all horizons. So other point is legumes included. If the legumes are included in the cycle or in the rotation, legumes, they add or they fix nitrogen in the soil. So if you add legumes, it means nitrogen, you're also fixing nitrogen to the soil. So it also help to control specific crop weeds such as witchweed. So crop rotation also helps to control specific weeds such as witch weed. Let's now look at regulation of soil pH. So soil pH is the degree of acidity or alkalinity, acidity or basicity in the soil solution. So pH can be regulated through the use of organic manure. So if you are using organic manure, you're also able to regulate the soil pH. Use of acidic fertilizer, stroke acid forming fertilizers. So if you are using acid forming fertilizers, it means you are also able to regulate the soil pH, more especially when the soil is basic. If you are using acidic fertilizer, it means you are regulating the soil pH. Use of agricultural lime. So agricultural lime, it also helps to maintain soil pH, more especially when the soil is acidic. If you add lime, it means you are neutralizing the acidity. So agricultural lime also helps to regulate soil pH. So good soil pH has the following benefits. It ensures availability of crop nutrients. So some of the crop nutrients are available when the soil pH is good. So if I've got more acid in the soil, some of the crop nutrients are not available. If the soil is basic, you find that some of the crop nutrients are not available. But if I've got a good soil pH, which is neutral, it means you are ensuring availability of crop nutrients. There is also it also increases the population and the activity of the soil organisms. So soil organisms, they also work well when the soil is, when the soil pH is good. It also determines the type of crop to be grown. So it also determines the type of crop to be grown, because some of the crops, they grow well under acidic, others they grow well under basic soils. So you are able to know which kind of crop to grow based on the soil pH. Let's look at controlling soil erosion. So soil erosion leads to loss of fertile soil, making the soil less productive. There are a number of practices that a farmer can carry out to reduce soil erosion. So if there is soil erosion, it means soil nutrients will be lost, since soil erosion is remove of top layer of the soil, which is fertile. So in that way, it means crop nutrients will be lost. So some of the practices which can be carried out to reduce soil erosion are as follows. Talk of mulching. When you mulch, it means you are reducing direct rain drops. Therefore, you are preventing splash erosion. You talk of growing cover crops. Cover crops, they cover the soil. So in such a way, you're also reducing soil erosion. We talk of strip cropping, contour farming, terracing. All these practices, they help to reduce soil erosion, and also use of cut-off drains. All these practices, they help to reduce soil erosion. Let's look at ensuring proper drainage. So waterlogged soils are not suitable for crop production apart from paddy rice and cocoyams. So the other specific crops which grow well when the soil is waterlogged. These are rice as well as cocoyams. So waterlogging can be caused by a number of factors, and ways of dealing with it also vary. So some of the factors may include draining excess water. So if you are draining excess water, it means you are ensuring proper drainage, or you are removing, you are avoiding water lodging. Then application of organic manure. Application of organic manure also help to improve drainage. Then we've got breaking hard pans if present. So if the soil has got hard pans, you have to break them, because those hard pans also, they are responsible for water lodging. So breaking the hard pans to reduce excess water in the soil. It's very important. So let's now at timely weed control. So weeds, weeds they compete with crops, or they use the same resources that crops use. So some of the resources talk of air, water, minerals, and space. So some weeds are alternate hosts, or they keep the crop pests and diseases. So if weeds are kept in the field, it means the crops can be easily attacked by pests and diseases, because some of the weeds they have a pest as well as diseases for the crops. Therefore, weeds should be controlled um, at the right time before serious damage is done. Though there are several methods a farmer can employ to control weeds, and these methods they are categorized into five: legislative, cultural, mechanical, biological, as well as chemical. These are categories of um, uh, weeds control. So let's look at practicing minimum tillage. So overcultivation destroys the soil structure. So if you overcultivate the soil, means the soil structure will be destroyed. So a farmer should therefore reduce the tillage operations as much as possible. So minimum tillage improves soil fertility in the following ways. So when talk of zero tillage, this is when there is zero disturbance to the soil. Just have to make the planting stations, you put your manure there, and you plant. You cover the soil with mulch, and if it comes to controlling the weeds, it means just have to um, apply the herbicides to control the weeds. But there is zero disturbance to the soil. That is minimum tillage. So minimum tillage improves the soil fertility in the following ways. One, it maintains the soil structure. So the soil structure is maintained. Why? Because there is no disturbance in the soil. Then it conserves the soil moisture. So soil moisture is also conserved. I've talked of mulching. You mulch the soil. It means there is little evaporation of moisture from the soil. The other thing is reduces root damage and disturbance. So there is no disturbance of the roots since the soil is not disturbed. Okay, if it comes to weeding, you just apply the chemicals, so the roots are not disturbed. So reduction of soil erosion. We have talked of maintaining the soil structure, whereby you're not destroying the soil. You are not disturbing the soil. If you are disturbing the soil, it means it can be easily eroded. But in this case, the soil not being disturbed. Therefore, there is reduction of soil erosion. Let's look at practicing intercropping. So this is the practice of growing different types of crops on the same piece of land. So you grow different kind of crops on the same piece of land. So intercropping, it helps to maintain soil fertility in the following ways. One, it ensures maximum utilization of the soil minerals. So there is maximum utilization of soil minerals since we've got different kinds of crops on the same field. So legumes, if the legumes are included, the legumes they help to add nitrogen, or they help to fix nitrogen to the soil. So in such a way, it means we're improving soil fertility. Providing better ground cover, hence controlling soil erosion and smothering the weeds. So if you plant different kind of crops on the same field, it means you are providing ground cover. So if there is ground cover, it means you are controlling soil erosion, and also you are smoothing the weeds. So this activity for you. So try to visit the area around to identify if the crops are growing on fertile soil, or if the crops are growing on infertile soil. Based on the characteristics, you'll be able to note on the crops. You'll be able to tell. Are the crops growing on fertile soil or are they growing on unfertile soil? So the other thing is I've got this exercise for you. So you can provide, you may try this exercise and you may try to answer in our comment section, and there are answers to be provided for you so that you should be able to compare uh, between what you have answered and our answers here. So the questions are as follows. The first one is define the terms of soil fertility. Then list 4 differences between fertile soil and infertile soil. State 2 ways by which each of the following maintains soil fertility. A, I've got crop rotation. How does crop rotation maintain soil fertility? Minimum tillage or zero tillage. How does it maintain soil fertility? Then give 4 other methods of maintaining soil fertility. So thank you very much for being there. If there is any question, that's our WhatsApp number and our email also is there. So thank you very much. See you in our next video.